part, or this next chapter, we're going to deal a lot with fractions and decimals. So, as I've said before a little bit, one of the biggest problems that I've seen in this school since I've gotten here is decimals and how to round decimals. I don't know why it's such a big problem, but it's a really problem. Okay?
Can a decimal number be negative?
Can a decimal be negative? Sure, why not? If you had some kind of percentage for an interest rate or something, or your return on something that involved interest at a bank, you could have negative because of the times we're going through right now. You're not getting money back, so then it could be a negative. Okay? So, today we're going to concentrate on writing fractions as decimals. And we're going to change them to decimals. So, how do we do this? How do you take a fraction and make it into a decimal?
Move it 2 places to the right.
Really? Move what?
The top. Yeah, the top number 2 places over. No.
Miss Kramer?
Decimal to the right 2 places.
Well, we're starting with a fraction. How do I take a fraction and turn it into a decimal? If I have 4 over 5, how do I turn that into a decimal?
Oh, yeah, put it around here.
I know you were. So is Miss Kramer.
You take the denominator to the next number with a 0. And then so if you're trying to get to an actual number and decimals and how much you have into it, so basically 5 divided by, let's say 1 is 10, that'd be 5 divided by 2, so that'd be 22.
Are you guys just making stuff up now?
0.8.
You take the number and get it to 100. Try to.
You really haven't never done this before?
We haven't done
To take a fraction to a decimal, you are going to divide the top number divided by the bottom number. Holy cow, that took a long ways. So again, top number divided by the bottom number. So if you don't have a calculator, we got to go old school, right? We're taking 4 divided by 5. Right? So obviously 5 doesn't go into 4, so we put a decimal down. This is where we get our decimal. And how many times does 5 go into 40? 8 times. So my fraction and decimal that are the same number are those two things right there, right? But I'm taking the top number divided by the bottom number. Every single time. So how do I find out what I got on my test today? How do I find the percent, right? The percent is just a specialized decimal, so I would take the top number divided by the bottom number, and that would give me a decimal, which I can move 2 places to the right, which I think that's what you two are thinking about, and then we would have a percentage. But that's carrying it one step further. We're just looking at the number right out of the total number of questions. That gets me a decimal. So if I get 4 out of 5 right, I get 80% in a sense. Okay?
Could you just change it to change the 5 to 100 and then just do how many times what could you?
Sure, you can do that.
You could, that's basically unreducing. Is that what you mean?
Yeah, take
Unreducing.
So you're going to say, turn this into 100 and say, what did I do to 5 to get to 100? So I'm going to multiply this by 20.
That's
So
what I
I'm
was
going to
saying.
multiply this by 20. So that gets me what?
80.
80. Does that help me into a decimal though?
And then you move it. And then you move it to left twice because of how many zeros there are.
What?
Oh, okay. So I can do this.
Yeah,
left.
how many, you learn how many zeros you have is how many times you go
That's
left.
what I was saying earlier.
Okay.
That's
So yeah, you can do that, but if I have a calculator and I punch in 4 divided by 5, it's gonna be way faster.
Yeah.
You know what I'm saying? So yeah, you can do this all the time.
You could reduce that one into making it 5 times 2, because then it would be 10, don't you? And then 5 times 2, then 4 times 2, because 10 is more than 2. 10.
I mean, you could.
Place.
You know.
Like 2 times 4.
Connect's always trying to figure out some wacky way of doing things, isn't he? At least he's thinking. You're right. I see what you're saying. You're turning these into 10s instead of 20s. And so then I would have had 8 tenths, and 8 tenths is really my decimal. I can do that too. Okay. But when we start talking about these, some of these fractions we should just kind of know by now, right? So one of these is, if you have 4/5, you should really know what that as a decimal is pretty quickly. What are some of the others? I should know 1/2, right? 1/2 is what?
This is.
What's 1/3?
0.3.
0.3. So, what do we call those kind of decimals? What were you just doing with that number 3?
Continuous, like.
You're repeating that number, right? So, how do I show repeating decimals if I write them like this?
What?
How do I show that decimal is repeating over and over and over again in a number?
To the power?
Times 10 to
No.
infinity.
Pi?
What? Well, mine goes on forever, so I was just thinking.
Well, you can't just throw pi in there whenever you want.
It's only for certain fractions.
Put a little line over the top of it. You ever seen that before?
No.
Holy cow, we learned something then today, right? So, this right here signifies a repeating decimal. Now, when we talk about repeating decimals, we could have just a portion of the decimal being repeated, or we could have the entire decimal being repeated. So you got to be kind of careful where you put that little line over top. So, example of repeating decimals, this right here is what Mr. Kolbeck was saying. 0.3333333. What's another way of showing that that goes on forever?
So that's limit.
What would I put down over here?
Dots?
Dot, 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 right? And that just says that my 3's keep on going until I get tired of writing them. And then they still keep on going, right? So, that's what that means. But if I have this, with my line over the top, the 2 and the 3, then this is actually 0.232323, and so on and so forth. So whatever the bar is over top of is the part that is being repeated. So I could have more than one thing being repeated, and then I repeat it continuously on and on. Okay?
What if it's just over the 2 and not?
It'll never be over just the first number, but it could be over just the last one. So that's a good question. And that was what I was gonna get to next time. So you could have 0.475, for instance, and then if I had it just over the 7.5, my 4 would be staying right there, and then I would have 7.5, 7.5, 7.5 until I got tired of doing it again. Okay? So that was a good question. So, repeating decimals are shown with a little bar. Okay with that?
Could you? I was just thinking of,
We'll come back to you. Think about it.
right after these messages.
Try to get those thoughts in your melon to form into words. Okay?
I don't think they're dots, they're just like straight lines.
All right. So 1/2 and 1/3. Other ones. 2/5. Any idea? What 2/5 as a decimal is?
1.4.
0.4.
3/4.
2/3.
66.
0.6 repeating, right? What else up there? 1/5 we should know. What's 1/5?
0.2.
0.2, okay? 3/4 is a big one, 0.75, okay? We already said 2/5, didn't we? Yeah. So, 1/4. What's a quarter?
25.
0.25, right? So again, anytime that I have something with a 4 on the bottom, we can think about dollars, right? How many quarters are in a dollar, right? 1, 2 would be 1/2, or 50 cents, and so on and so forth. So those decimals right there, you should start to really recognize, and you shouldn't ever have to use your calculator or any other thing to do all those. All right? So, we have two different kinds of decimals then. The repeating ones, what do I call these decimals that stopped?
Terminating.
These are called terminating decimals. What does the word terminating mean?
Like, get rid of. If you exterminate, like, bugs.
Yeah, but we're not exterminating it, we're terminating it. If you got terminated from a job, what happens?
Fire.
You're fired, you're done. It stops, right? Your job stops. So, terminating decimals are decimals that stop. So again, vocabulary word. We're terminating, not exterminating them. We don't exterminate decimals. Okay? So, any fraction we can do this to, with these fractions that we listed right here, we hopefully don't even have to do the division or use a calculator. But if we have something like 2/7, then we probably want to use our calculator. So punch in 2 divided by 7 in your calculator, and what do we get?
0.28571.
28571.
42286.
142.
There's not 2 ones.
Okay, 86. Something like that. All right. So here's the question. In that respect right there that Alex just read, is that a terminating decimal? Do we know that for certain?
No.
Why?
Because there's a lot of numbers.
Okay, but why else? Just because my calculator told me that answer, did everybody have that answer? Basically? Does that mean that it ends there? Not necessarily. It just means that we ran out of room on our calculator. Or the screen, right? So you got to be careful if somebody asks you, is this right here a terminating decimal? Because it could have kept on going, and then if it keeps on going, your calculator would automatically just round this last number because it ran out of space. That makes sense? So it's kind of a trick question, and we don't really know the answer to it unless we would actually do the math. And not too many of you are going to take the time to do the math because we can't multiply, and division's harder than multiplication because we couldn't do 8 to the 9th the other day.
What?
Right? All right? Makes sense though what I'm saying there? And the calculator will never have the little line over top to say that that's repeating or something's repeating. Or they won't put the little ... that this one actually could go on forever and ever. Or as the thinker over here in the corner was yelling pi all the time, right? Pi is one of those decimals that originally they thought it went on forever. But I think actually somebody found an end to it now. So that was somebody that's really smart and did a lot of math.
It's not you.
Okay? Put your hand down.
There's like a number, and it's like a whole bunch of like 3s, but then there's like 6 at the end.
Exactly right. So then that would be a terminating decimal. The only time that it might be odd would be if there's a bunch of 3s and then this one said 4. Or a bunch of 3s and this one said 3 still. Then I'd say it's probably repeating and they either rounded it or they just... Alright, let's go. Inspire us all.
Explain.
Come on.
Read? Okay, so
Okay, no.
if you put space over board, write space, and then put that line over it.
Wait. Space
Yeah, right space on the board, and then you put that line over it that shows it goes on forever, so that means like there's infinite space on that board.
I thought you were smart enough to go to 8th grade already.
What, Nathan? Oh yeah, Nathan said in language today that he could go all the way to high school.
This is what he's saying right here. This is what I got. He's saying, why don't we just write this word here and then put a line over it and say, there's just infinite space there. That's what you're saying, right? Okay. Next time you have a question, ask Addison first. And then she'll give you permission to talk out loud. Got it?
Addison, that basically means.
What if you had a 1 and 3/4?
Okay, great question. Great question. He said, what if I have this as a problem? So first off, what's this kind of number called? This is a mixed number, right? So more vocabulary. Why is it mixed?
It's
Whole number
whole
and
number
numbers.
with a
Perfect.
fraction.
Okay, so Jacob's question is, well, what do I do with mixed numbers? Okay, two options. Okay, option one, I could do the fraction part the exact same way that we just did it over here. Okay, and then we would say that 3/4 is what decimal again? 0.75, and then I would put my whole number out in front. Okay? Or I could take this mixed number and convert it into an improper fraction. What's an improper fraction?
It's
So the number that's,
the numerator
the
is
numerator is
bigger
bigger
than
than
the
the denominator.
Perfect. The top number is bigger than the bottom number, right? So with respect to this mixed number right here, what's the process of taking that number and turning it into an improper fraction? What do I do? How do I turn this into an improper fraction?
Add the whole 4 that you already have with the 1 and put on with the 3.
Make the one a fraction.
We don't know how to do this either? Cool, we're learning a lot today. So, here's my process. I think we're on the right track. But you would take the denominator times the whole number and add the numerator and put it all over your original denominator. So, do it as we just said. What's the denominator times the whole number? Plus the numerator. So my improper fraction is 7/4. And I think that's really what Jacob was getting to. Or maybe I'm just giving him credit. But.
No, I was getting to that.
So then, all I would have to do is exactly what we said at the beginning. I'm just going to divide the top number divided by the bottom number. So this right here, converting it straight down, is probably easier, especially if I know what that fraction is. If I don't necessarily know what that fraction is, then I'm going to have this, and it's still going to roll around and get me into a number with decimals. So if I punch in 7 divided by 4 into my calculator, I should get 1.75. Right? So let's try a couple of those. Let's say 2 and 7/8. So 7/8, you might know that as a decimal, but it wasn't as one of these. So we can't just jump to this process that we went to first. So I would convert this into an improper fraction and then punch it in my calculator. So first things first, what is my improper fraction that 2 and 7/8 converts into?
23.
16 plus 7? 23/8. And now punch 23/8 into your calculator. Here we get what?
2.875.
Perfect. Makes sense? And it makes sense because we should have 2 as our whole number, right? And then so 7/8 would be 0.875. All right? Where is learning? So, Mr. Question at the beginning was, can I have a negative? Sure. So, write that fraction as a decimal. So again, my answer better have a negative out in front of it. But then I'm just going to stick it in my calculator. And what do we get?
Negative 0.12.
Both numbers? Perfect. Okay. Everybody agree? Okay. Try 2 and 2 over 25. So first convert it into a mixed number, or sorry, into an improper fraction, and then figure out what it is as a decimal. Now, the reason that I urge you to turn all of these into improper fractions, from here on out, if you end up with a fraction answer, I would leave all of your answers as fractions and not use your calculator and turn them into decimals. If you have fractions, when you get into Algebra 2 and pre-calc and calculus, it's going to be way easier to work with than decimals. Okay? And you'll find out that 23/8 is way easier to work with than the mixed number of 2 and 7/8. So those are just little things that you should try to get used to. So what do we say for 2? First off, what is my improper fraction here?
52/25.
52 over 25, and so we convert that into 2 and
8.
8.
800.
0.08.
I actually got it. I did that. I did it too.
I knew I saw smoke over here.
I'm not seeing it. I hydro electric power.
It's too hard.
Where's the water?
Yeah, she said that.
Our body is made of 70% water, so I mean. Yeah, will we be cannibals if we drink water?
Only if you drain it from yourself first.
You're supposed to have
Oh,
you're
my.
supposed to have
So if you
daddy-
lick somebody's sweat off, yes, you're a
Ew. What happens if you drink somebody's pee on back page? Right?
You can survive off that.
Nathan, you're supposed to ask Addie if you want.
Yes.
All
Alright, questions here?
Punishment.
Questions here? So the next part that we're going to look at is how to compare fractions. What do I use if I'm going to compare fractions? Any idea? What symbols would I use to compare things in
Greater
math?
than, less than, equal to.
Perfect. So, less than typically looks like an L, right? If you tilt your head. Greater than typically is obviously the other way. And then we could have, as you said, equals to. Now, when we talk about less than or greater than, one of the things that you have to realize is how you're reading the problem. So, in most cases, they always want you to read from left to right. Now, when we do these problems and we're comparing, we're always going to have it, the symbol point towards the smaller number. And in some cases, they talk about these kind of looking like alligators or something, so it looks like it's going to, quote unquote, eat the bigger number. But what I'm getting at is, you have to be careful how you read these and in what direction you're going to read them. So, some of you might always write it as left to right, like you would normally write things, and read it left to right like you would normally read things. Some of you might just look at the symbol and try to figure out if it's less than or greater than. I myself would always try to go left to right. It's going to be way less confusing. And if there's a variable in the problem, I would always write the variable first. Now, we're probably a little far ahead of ourselves talking about that variable right now in this instance, but just realize if I wrote this and I wrote this, are those two things the same thing? Why? Because it's always pointing towards my variable, right? But if I read this one, I would read this one as x is less than 7, right? But if I always read it as left to right, I would read this one as 7 is greater than x. So even though it's the exact same problem, the way that I read it or tell somebody else about that problem could get a little confusing if we're not all on the, kind of the same page. Understand what I'm getting at there? Okay? So, we're first going to just look at comparing fractions. And so, this is where, if you have no idea, they might put a box here, they might put a line there, they might put a circle there. That's just telling you to fill that in with less than or greater than. So if I can't tell by just looking at the numbers that are given to me, then I have to convert it into the same thing. So we'll finish this up tomorrow.
I have the funnest idea.